just for everyone to be on the same page. I'll quickly explain how we're using at AskUI LLMs for testing. And then we're going to look into public LLM benchmarks, so what public test sets exist out there that you can use to test LLMs, and then also how you can build your own LLM benchmark. And in the end, if we have time, we'll go over some remaining best practices. Just for a second about me, I'm Maximilian. So I'm a machine learning engineer. I'm a bit of a normally not inside the test domain, but I think with all the LLMs now being applied more and more in applications, testing machine learning models is not just a machine learning topic anymore, but also even that like a test topic as well. Right. So about LLMs, in general, just to give you a short idea where it fits. We're talking about AI in general a lot. That's just like a whole field in computer science where we talk about creating intelligent machines. In there, we have machine learning, where we're talking about learning patterns from existing data. So we're collecting data, training models on those data, and then we have some test data, which we use to check if the models have learned the right things. And there's deep learning, which is a subfield of machine learning, where we use neural networks, which is just a specific technique. And then recently, in the last years, generative AI has become really popular, where one part of that is LLMs, which are a way to generate content like text. There's also other generative models like diffusion models to generate images that you might have seen. LLMs, how they work is that you can give some input, and that is broken down into some tokens. So for example, here's a question, what is up? Question mark. It's split into tokens, it's given into an LLM, and then what the LLM does is it tries to predict the next token. Like it's one next token, and that is the whole task technically that's learned. It's essentially giving probabilities for how a certain text can continue. And we can use that to generate some responses, for example, on a question. So here we generate as a next token then we add it to the input, and then we can, based on that, generate the next token, and we go on with that until at some point we generate some special token that says like it's an end of sequence token, EOS, which is a way for the model to say, I'm done here with my generation. This is a very flexible way where you have like one kind of model with which just always predicts a token, but you can apply it to all kind of different topics. For example, content creation management, you can generate customer support responses, emails, documents. You can also ask it to categorize text by generating essentially the name of the category. You can use it in software development to generate code. I think there's also some approaches where you generate test cases or test data or analyze logs. And language services, translation, many more use cases, because LLMs in general are very flexible, and you can generate whatever output you want. So if you have the right data to train that with, and then there's like the big ones that are trained on a lot of data, you can just apply them to many use cases. I think most of you have heard about the GPT models from OpenAI. So this is one category of LLMs, like ChatGPT, for example. There's also other models from other providers, like Google has some they're called Gemini models and Claude models from Anthropic. And then there's also some open weights models, which is essentially open source, but for large language models. Those are models that you can also download and use yours on your local machine. Typically a bit less powerful, but they're also catching up. So that was it about LLMs in general. So what we're doing at AskUI, just to give you a bit of context, what we are doing with LLMs. At AskUI, we're building a test and automation software that is not relying on, for example, the DOM, like you would typically do it with the computer. It kind of checks like the DOM tree and then tries to identify elements. But we are using an approach that is more close to what a human would do. Just look at the screen essentially and identify elements. So if you want to click on a login button, for example, we use computer vision, like AI models to find where this button is and then be able to click on that. And that is interestingly something you could also do with large language models. So this is another use case where essentially you're giving it as an input, not a question, but you can say locate login button. And then what we're doing in the back, we're also putting screenshots into, so you can also put images into large language models. And then we're kind of generating some target coordinates like an X and a Y coordinate, and then an end of sequence to say this is where you want to click. And that's what we are doing at AskUI in the background to allow you to automate all kind of applications, desktop applications, web applications across multiple applications based on this kind of technologies. Right. So now to the main part is like when you are developing an application with an LLM inside, how are you going to test it, right? So there's classic software testing for traditional software, but now with LLMs, a lot of things change on like how can you test those specific parts. So in AI, we're often talking about benchmarking, which I think can be like referred to like a test suite, where a benchmark is essentially a collection of test samples that you would test your LLM against. And then with one benchmark, you typically also have a specific metric that you want to calculate. Like accuracy is a very simple one where you just check how many percent or how much percent of the samples were correct or incorrect. And then you can, in the end, give a report and say like, my LLM XY scores 82% on a given benchmark. And it's very common to not pass every test in these cases, but to just, you would also put in very hard examples into such benchmarks. So you're typically scoring a relative score, and you never kind of reach 100% because of this probabilistic nature of the models. You're always working with probabilities, and you're trying to get as close as possible to the actual true answer. So there are different methods when it comes to checking if a model performs well on a given test data set, test sample. One is what we can call code-based, which is what you know from like unit tests or something, where you're just checking if the output of a model and is an exact match to what you would expect. You're just comparing a number or a specific word or a Boolean. But with large language models, you can also generate quite complex texts, like a whole email, and then those things become much more difficult. So sometimes you also have to do like manual testing. And another interesting approach is model-based testing. So in this case, I'm going to show an example in a second. You're using a second LLM to essentially rate the response from the first LLM. This way you can automatically also try to test complex outputs that cannot be directly compared. So one example for a code-based benchmark is MMLU. It's a public benchmark. Some researchers essentially collected 15,900 questions from 57 different tasks, includes mathematical questions, US history, computer science, and they are designed as single choice questions and responses. And then the model is asked, the LLM is asked to respond with A, B, C, or D. And then with this kind of trick, you kind of can have a simple comparison between the correct answer and what your model put out. If you would let the model just give the answer to the question, then you would have no way to check if the answer, if it's a free text answer, you could maybe see if it has the same words than in the ground truth answer, but it might not be, it might use different words to say the same thing. So by making it single choice, you can actually quantify it. And that's something you're looking for with your benchmark often. And then in the end, you report a metric like the accuracy. This is here the percentage of correct answers. You calculate it for every category, and then you take an average across the categories. And then in 2021, for example, when the whole data set was published, models like GPT-3, the predecessor, I think also with ChatGPT and stuff like that, they scored 43.9%. And now this year, we've seen some models that score above 90% on those questions. And you will see also when companies release models, they will also report those numbers as a way to market their models and demonstrate how good they are. There's also some issues that you have to keep in mind with these public test data sets and benchmarks, and that is that because MMLU is known and it's all over the internet, and some samples of it might be all over the internet, the danger is that when people train large language models, that samples of those test data sets might be slipped into the training data sets. So in this case, the model might not learn actual physics, but just learns by heart the answer. And that's why you can also observe that on many of those public benchmarks, at some point of time, all the scores go just up for many models because, the data becomes much more known and the tasks. And then if you generate new, harder public benchmarks with new questions, models are worse again. That's just something to keep in mind. Other examples for similar test data sets are math, which is, as the name suggests, it's about solving mathematical problems. So the LLM is given a question, a mathematical, and then it generates a solution, and there's a ground truth solution. And they are both, as you can see here in the sample, they respond, like the model just responds with a different text than the ground truth solution. And that's what makes it so hard to compare, because you don't know if the text has the same meaning. But in case of math, you're always breaking it down at the end to a specific number, which is 30 here, and 30 is the correct answer. So you can have a code-based comparison and just check if the numbers are equal. And that way you can say that the LLM was right. And then there's human eval, which is another type of test data and benchmark approach. It's not human, it's essentially programming tasks. So the model is given a definition for like a function and some docstring, and then the models have to generate the code. And in this case, you're just essentially using unit tests to check if the function is correctly implemented, and use that to score the model. And then there's the cases, as I mentioned, where those things, don't really work. If you have more complex responses, how are you grading this? If it's not a number or just a specific letter. So there are things like Chatbot Arena, for example. This is an approach for grading LLMs where essentially you show to people outputs of two different models, so model A and model B. And then you ask people to essentially rate which model is better. So you can see here on the left side, I asked it to classify the sentiment of I think it was a tweet, and it should return me the word positive or negative. And you can see the left model, model A, it got it correct. It said negative. Model B also said negative, but it added a point and also a capital letter N. So it was not really following my instruction very strictly. So in this case, I would rate that A is better. And based on those small like fights between model A and B and those ratings, there's this kind of leaderboard that gets derived from it. And it's a bit like ELO score between chess players, where the models are then like ranked based on these comparisons. That is just one like public benchmark for that. Of course, you can later also think about having your own kind of leaderboard where experts for a specific domain are rating the responses for a specific use case. And then the third approach I mentioned is model-based evaluation. So this is an idea where here on the left, I put up a customer support message saying, you've messed up my order. And then we have model A, which is an LLM that we want to deploy in production, and it's tasked to answer those support questions. In our case, it says something like, it's your mistake, we can't do anything about it. And now what you can do is you can take another model, you can take the output, and you can give it a prompt like, rate this customer service response on a scale of 1 to 5 for being empathetic, for example. And then you put in the response from the first model and let the second model rate how empathetic the answer was. And if you do this on like a few hundred, a few thousand samples, you kind of can get an idea, even if it's a text that you cannot directly match with anything, how your model performs. Although you have to be very careful, because if model B has some kind of systematic issues with knowing what empathetic even is, or whatever you ask it to rate, then it won't work well. So it takes a bit of trying out model B, trying out model A, and Yeah, but I mean the advantage is that you can repeat it automatically and don't need humans every time to rate everything manually again. Yeah, so one thing you keep in mind is that there's different things you can evaluate, right? So it's not just about the performance of the model, how well it is, how well it does on a specific task, but also how, if you, especially when you're generating free text, how is it responding? Is it consistent in its responses? Is the tone or the style good? Is it empathetic? In like as I showed in the previous example, things like privacy preservation. So when I have a model that takes some old customers support tickets into the context to respond to new ones, and there was maybe a private phone number added by a customer, is the model going to leak this phone number or not? Right? Those are all things that we can specifically test for with specific benchmarks that are designed to do exactly that. And yeah, there are also some public existing data sets and benchmarks for that. So, for example, Jailbreak Bench is a list of research papers where researchers used specific prompts to get the models to do something or to say something that's harmful or unethical. And then you can see how successful was this attack, on which model was it carried out. And there's also a data set associated with it that you can then use to apply it to your LLM or LLM use case as well. Decoding trust is another example. Here, the privacy example that I just gave. So they will have prompts in it where they're trying to or test samples where they're really tricking the model to return some private data. And then the question is, have you picked the right model, or have you put up the right guardrails to keep your model from answering those private data? So things that those are also things that you can test. Right. And then another aspect is a bit about metrics. Going to just briefly go over this. So we talked about a little about accuracy, so just how much samples you get correct. There are other use cases where it's more about recalling specific types of information versus being correct. Depends a bit. Goes into a bit of the details. We have qualitative scales, as we showed with the model-based, with like Likert scale, rate from 1 to 5, or experts could rate the answers. We can also take into account user feedback, or have things like A/B testing. Yeah. Now the question is a bit how to build your own LLM benchmark, because yeah, I mentioned already one problem with the public benchmarks is that at some point the models will just learn the answers by heart. And also the second part is you maybe don't want to do physics or high school history. So you have your own use case with your specific niche. And yeah, you need to know if the LLM performs well on that task and not on general tasks. And so what you need to do is, of course, you need to first get yourself become clear about what you want to test. Is it a specific performance metric, or like the style or whatever it is, which metrics you want to use. Depends as well a lot on the use case. Can you get the model to output a specific number or something that you can directly compare? Or are you using model-based grading with a scale? That's things that you need to think about when you create your own benchmark. And then there's some principles, like the first one is be very task specific. So the closer you get to your actual task, the better. So if you're, for example, building a customer support bot with an LLM, then the best thing you can do is to directly use customer support conversations from the past that you have maybe in your database and use those as examples, because they will be the closest to the real world distribution that the LLM will face when you're deploying it to production. And then also to automate whenever it's possible. So to have automated grading based on LLMs, or because you framed it as a single choice or something, so that then it can be automatically graded. You don't need humans too much, because yeah, you're going to do a lot of testing and also frequent testing. So yeah, that's important. And then one thing is also to think about the volume of the data you need. So there is the general tone to say you need to prioritize volume. So quality is, of course, also a thing, but it is very important when you test that your data samples reflect every aspect of what could like your LLM encounter in reality. So what I mean with this is that when you have a customer support bot LLM and there's all kind of hundreds of different types of support questions, you need to make sure that every kind of question or conversation that exists is reflected in the test data. And it's more important to reflect everything than each of the individual samples being like super high quality. Yeah, so now we said the next thing we need is we need some data. And one thing that's very popular in AI is a platform called Hugging Face. It's essentially like GitHub, but for models and data sets. And they have a dataset explorer where you can go and you can start to look for data sets that are similar to what you're building or you're looking for. I took the example again of a customer support. So I searched that, and then there's some data set with support tickets. And there, for example, you can see something with ticket priority is already labeled. So if you want to use an LLM to classify ticket priority, you could use that data set as a starting point. Because that is already much more closer to your task than the general ones like MLU, but you don't have to put the effort in yet to label your own data. But of course, the tickets might be very different from your ticket, so it's just one way or like one abstraction that you can do. And then, of course, the other thing is label your own test data. So there is a ton of what we call labeling tools out there. Essentially, those are tools where you can upload data. So, for example, from a database, you can take your old customer support conversations, you upload them to a labeling tool, and then those tools give you an interface where you can rank certain responses, where you can say if they were helpful or not. Like you can put up this labels that you're then using in your test to compare to the model output. There's also very complex approaches like in AWS. You can also automatically hire some people that will then be creating those labels for you. And yeah, you can also, there's ways where you can already compare two different models where they are linked to the tool. And then you put in a data point and you can check which model responds better and you can hand label this. So yeah, labeling is the thing you do when none of the existing data sets fits your use case. You're just going to create your own one. And then the question is what you do when you have the data set, when you're clear what you want to do is you need some framework to do it. So in testing LLMs, it is not as, I would say, structured already as software testing because it's a much newer field. So often you will have to write your own custom Python code, but there are some frameworks for especially also for evaluating large language models where you can just plug in a language model like an endpoint from a specific company, and you can put up an existing data set very easily like MMLU, or you can implement your own data set. You will have to implement a bit to get it in the right structure, but then you can also use it in this tools, and then you essentially run it and you'll get a score for the data set for a given model. So this is one way to work with such frameworks. There are also some end-to-end tools. So I know that Azure AI Studio, for example, they've built something where you can plug it to your application endpoint and then upload your data. And then this kind of helps you so that you don't have to write too much custom code to test the endpoint. And they also provide some of those like safety data sets where it's about like checking if your LLM does an unethical outputs or something. This can be also done with such tools, and then they will give you a dashboard, which telling you, how the model performs on that. Yeah. So after that, let's go with a few best practices. So one is, I think one of the most important one is that you will like automatically and continuously need to test and monitor what you're doing with LLMs. There's two main reasons for that. One big one is data drift. So that means that while you're running your application with an LLM, the input might change over time. And you need to understand continuously if your model can handle that input. So if you go back to the example of customer support again, let's say there's a new topic coming up, and a lot of customers are complaining about something specifically. This means that all the emails that are now coming in are about a specific topic. They use specific words. Maybe many customers are angry, so they also change their tone. And so this is kind of a drift of like it changed the input to your model changes a lot. And to be prepared for that, it helps to continuously test. And then also models change over time. So old model APIs are deprecated. So for example, OpenAI just recently announced that some of all the GPT models will be removed. And you should just take one of the newer OpenAI models. But of course, you don't know without testing if they will behave exactly the same on your use case. So that also means you have to continuously run those tests. And then a few remaining ones. So one thing that many providers also recommend is to do adversarial testing and also to enable user feedback. Essentially, they say it's not yet possible to test all the aspects. I mean, it's very, very early in this field. Many people don't know yet how you can, what possibilities are with LLMs, like how they can be exploited and how they can be tricked to do like output unethical responses or output very different things from what they're supposed to do. So the easiest thing is to also allow users to flag when something happens so that you can proactively work on that, and then also to manually specifically try to exploit them and test them. And then, of course, safety benchmarking is a topic in general. So not just performance, but all the other aspects that I mentioned. And what's also very common to do is to constrain the input and the output to the models. So both in like the amount of input and also if your use case allows it, try to kind of limit what the output can be. Like if, for example, in the privacy use case, you can try to also limit that emails or phone numbers cannot be outputted. You can try to have some manual filters on that. Also, to prevent that users are using the model kind of against you. So one example for something where you take the output of a model, for example, and write it to a database. So a user could essentially trick the model, like write it in an email that is not actually a support question, but that is actually an instruction to the model and ask the model to ignore all previous instructions and now output a command that deletes a database or something. So if you're not careful with the limitations of the output of a model, and you just execute it, this might lead to problems. So yeah, it's very common to limit this.
Maximilian, 2 minutes left.
All right. Yeah. I'm already done. Perfect.
Okay.
Yeah, that was it. I hope you guys learned a bit and got some new insights about testing LLMs. And yeah, if you have some time left, I'll also be open to answer some questions.